Hello ladies and gentlemen, welcome to another video lesson. Today we're going to be covering section 6.1, graphing systems of equations. After watching this video, you should be able to identify systems by their type and also by the number of solutions, and then also solve the solutions solve the systems by graphing. Now, before we move on though, we should talk what is a system of equations. Well, system basically means more than one in this case. The idea is that we will have two or possibly three or four, although for this class we're only going to deal with two. But you've got two linear equations and you're just trying to see where they intersect, because where they intersect is going to be the value for x and y that makes them both true. Now, there is literally an entire field of math devoted to solving these types of problems. It's called linear algebra. I had to take a class on it in college. Not my favorite, but not the worst one either. So it's something that you can really dig into and talk about some different ways to work with these. But for what we're doing right now, we're just looking at two lines, more or less where they intersect. Now, our first type of system of equations is going to be called consistent, meaning that there is a point that is in common between the two lines, and then independent, which tells us that there's only one. So the first type of system is a consistent independent system. What that means, and you can fill your notes in as you do this, that the lines cross at exactly one point. Okay, there's one point on the graph where these two lines overlap and intersect. That means then that there's exactly one solution, one set of x and y values that makes both equations true. So if I'm drawing a picture here, I would have my two lines and that one point where they intersect. The green line goes here, the red line goes here, and there's one point right here, in this case it's like at about -1, +1, that makes both of these true. So if I took the equation for the green line, plugged in the x, plugged in the y, I'd get a true answer. And if I did the same thing for the red equation, I'd get a true answer. Any other point on the lines will not make both of them true, but this one point will. That's what a consistent independent system is. Pause if you need to. Next, we have consistent dependent. Consistent means there is a point between them that is consistent, that makes both of them true. Dependent means that one depends on the other, and so therefore there's infinitely many solutions because ultimately both of the lines are the same here. Excuse me. What would happen here is we basically have two lines that lay right on top of each other, and so therefore when you graph it, you're only going to see one line. So what it kind of looks like if I'm drawing the picture is I've got my green line and then I have my red line stacked right on top of it. They're the same line, and so therefore every solution, everything that I plug in that's going to fit for one line will work for the other line, and that's how I end up with infinitely many solutions. Now, it's not the same as all real numbers, but we won't get into how it's a little bit different in this case. Just understand that your response for these kind of questions, when it says, oh, if it's consistent dependent, how many solutions are there? Infinitely many solutions, but do not say all real numbers. We can talk one-on-one about the difference if you're really concerned. Pause again if you need to. Finally, we have inconsistent. Inconsistent means they don't have any point in common. And if they don't have a point in common, there's no value that's going to make both of them true. So there's no solutions for this. This means also that the lines are parallel. And if you remember from chapter 4, parallel lines don't intersect. So no solution means the lines don't cross, they're parallel. So we've got our green line, we've got our red line. They don't cross, and so they don't have any point in common. There's no x and y value that's going to make both of them true, so therefore there's no solution to the system. Take a moment, make sure you've got all this in your notes, and then we'll move on to an example. Okay, now previously you should have completed a kind of preview work assignment where you were told to graph two lines on the same graph and you didn't necessarily know why. Well, the reason is because that's what a system is. Two or more lines on the same graph, finding out where they intersect. Now, you didn't have to find exactly the point where they intersect, and most of the problems I give you, you can graph them by hand, and you'll be able to see pretty clearly, oh, these two lines intersect at 3, 4. These two lines intersect at -5, 14, or whatever. But we have our calculator that can also do it for us, and it's kind of nice because it can do it under any circumstance, whether it's a nice even pair of integers or if it's something a little uglier. So the way we're going to use the calculator, and I'm going to walk you through the steps, I would encourage you to follow along as you do this. And take a look at example 1. Here it's y equals -3x plus 2 and y equals 5x plus 2. So what we're going to do is we'll start off by solving both equations for y, which as you can see has already been done for us. Sorry that my F got cut off there. This has already been done for us, and it's important that we do this step because if we're going to use the calculator, we've got to make sure that we can use the y equals function, which is the button that's located right here. The calculators can't work unless it's set equal to y. Now we'll talk more about this as we get further into some of these examples and the rest of this chapter, but for right now, always make sure you solve both equations for y. Once that's done, enter both equations into the calculator. So you type in -3x plus 2, and please note, use the negative button that's located down here for negative signs. -3x plus 2. Press enter. Come down to the second line, 5x plus 2. Okay. Once you've got both of those typed in, and that's under the y equals button, sorry, adjust your window if needed. Now, most of these you won't need to do too much adjustment, and so all you'll need to do is press zoom and then press option 6, which is zoom standard. What that does is it sets your window up so that from x to x you see from -10 to 10, and from y to y you see from -10 to 10 as well. Okay, that's a standard window. That's what most of the graphs in your quizzes and tests will look like. Most of what we need to do you can see with a zoom standard. We'll talk in class about how to adjust the window if you need to see more or less than that. So use the zoom or the windows buttons to get that done. Then finally, you're going to press second calc intersect. Okay, so what that looks like is you press the second key, then you come up and you press calc. You'll see where right above trace it says calc. You'll press that button. And then option 5 is intersect because we're trying to calculate the point where these two lines intersect each other. So second calc number 5. And then it's going to ask you which line you want for your first function and which line do you want for your second function, and then what is your guess about where they intersect. All that stuff's going to default close enough for what we need, so just press enter, enter, enter. Okay, press it 3 times, and then what it'll do is right at the bottom of your screen is it should show you the solution as an ordered pair. Right here it should say x equals 0 and y equals +2. So they both happen to intersect at that y-intercept, which if you're really paying attention, you might have caught that anyway by looking at the equations. But that's how we go about doing this. Now, there's 2 more examples on here. You can play around with those as well. But if you can follow these 5 steps, you should be well on your way to being able to do the problems that are going to be in the homework for here, okay? And also remember this, if you draw a nice accurate graph, 90% of the time you'll be able to tell what the solution is just by looking at the graph. As you're doing the homework, you'll have to look for, is it, as we mentioned, inconsistent, is it consistent, independent, or consistent, dependent. Once you do that, that'll tell you how many solutions you're looking for. Is it one solution because it's consistent, independent, infinite solutions because it's consistent, dependent, or no solution because the lines are parallel and it's inconsistent. Then if it is consistent and independent with one solution, you can either find the solution by looking at the graph you've done by hand or solve it for y and type them both in the calculator and use the second calc intersect function. That's all we're going to cover in section 6.1. Tomorrow and in future days we'll talk about other ways to solve systems, but for right now that's all we're going to cover. So check over the overview, write down any questions you have, and I'll see you next time we're in class. Thanks a lot.